fully supported wooden beam of span 1.3 meter having a cross section 150 mm wide by 250 mm depth carries a point load of W at the center. The permissible stresses for these beams are 7 MPa in bending, 1 MPa in shearing. Find the safe load W. What a good question which has been asked. This question is also a combination of all the 4 different things. Without the knowledge of all these things, a person cannot go ahead. Span of the beam which has been given 1.3 meter and the maximum bending stress permitted which is given is 7 megapascal. Maximum shearing stress permitted is 1 megapascal. And the cross sectional area given to as 150 mm, depth is 250 mm. Now, maximum bending moment permitted in this case is WL by 4, as once again if you are referring the previous one on this tabletop, please refer this tabletop figure, this previous figure. This is my bending moment diagram. Maximum bending moment acting at a center is of WL by 4. So, on this PPT, if you come across over here, WL by 4 is equal to W by 4 into 1.3, L is known to us. Multiply by 1000 to convert the whole thing in terms of mm. So we obtain 325 W Newton into mm. Now maximum shear force which is applicable over here is W by 2 Newton. So refer the figure once again on this tabletop. Visualize that maximum permitted shear force acting on this W by 2. So now, using the first concept about bending stress on this PPT, value for W for bending stress consideration using the fundamental equation M over I is equal to F over Y, that is sigma over Y, where M is equal to 325 W. I is equal to BD cube by 12, that is 150 into 250 cube by 12. By simplifying this, we achieve 1953125 millimeter raised to 4. Sigma is equal to 7 megapascal. Obviously, the maximum stress, please refer the figure on this, maximum bendings on this tabletop. Please refer the tabletop. Maximum bending stress permitted at top and the bottom fibers. For a rectangular section, Y max is D by 2. So here the Y max in this given problem is D by 2, that is 250 by 2, that is of 125 mm. So please come to this PPT. Y is equal to D by 2, that is 250 by 2, that is 125 mm. Substituting these values in this equation, M 325 W, I 1953125 not 20 is equal to 7 divided by 125, and simplifying this we achieve W is equal to 33,653.8 Newton, that is 33.65 kilonewton, that is the point load. Up to that much load, my beam will bear the bending stress value of 7 megapascal. Repeat the word once again. W, which is equal to 33.65 kilonewton load, if it is acting on my beam, it can bear the shear bending stress of 7 megapascal. Now, value of W for shear stress consideration, average shear stress is equal to shear force by shear area. Average shear stress, force by area, shear force by shear area. Shear force is W by 2, area is BD, so W by 2 into 150 into 250, that is the average shear stress. But in the data, the question is the value which is given to us is maximum shear stress, that is of tau max is equal to 1.5 times tau average. So tau maximum is equal to 1 megapascal. So 1 is equal to 1.5 cross W by 2, 150, 250. And by simplifying this, we achieve W is equal to 50,000 Newton. We have two answers right now. Let us we understood this concept over here on this tabletop. Simply supported beam, load W. Now this load W, one answer is 33.65 kilonewton, the another answer is 50 kilonewton. If I am applying this much load, the permitted sigma value is 7 MPa. If I will permit 50, it permits tau value is of 1 MPa. Which answer I have to accept? So be clearly visualize over here. One point is that if I apply 50 kilonewton load, then in that case the value of sigma which will acting on this cross section is more than 7 MPa, which is not permitted. My beam will fail. So I cannot apply 50 kilonewton. I have to apply less than that. That is of 33.65. So the answer for this given question is minimum of this two, so that it will satisfy this two both. My beam will be acting, the lesser value of these two answers gives the final answer for a given particular beam. So I have an answer. The safer load is the minimum of the two values, that is 33.653.8 Newton. So up till now in the today's session, we have discussed about the rectangular section and the variation of the shear stress acting on the rectangular section. We have solved the three different problems in connection with the bending stress, SF and BM diagram, as well as with the reactions. I wish you have catch up the fundamentals. Please solve more numericals at the home. We will solve more numericals and we will see the circular section also in the next section. Thank you.